All right, guys, today it's time to go over the practice and problem solving for lesson 7-3. Well, we've got number 7 starting us off. It says the table shows the result of spinning a wheel 80 times. What is the relative frequency of the event spin of the event of spinning a 3? Well, we see here 1 came up 8 times out of that 80 times. 2 came up 22 times, 3 came up 18 times, and 4 came up 32 times. That's weird. You would expect that each number would probably come up about 20 times because if you divide 80 by 4, you get 20. But that's not what the experimental probability guarantees. Remember, it's just what should happen, not necessarily what's going to happen. So the relative frequency of the wheel landing on 3 is, well, it's 18 out of 80. That's the number of times an event occurred, 18 times it landed on 3 out of the total number of trials, and that's 80. 18 divided by 80 is 22.5%. Remember, your calculator is going to say 0.225, but we have to move that decimal over twice to get the percent. Liz flips a coin 50 times. The coin lands heads up 20 times and tails 30 times. Complete each statement. Well, once again, we would expect that the theoretical probability of the coin landing on heads is going to be, 50% of the time. So you would take 50 and divide it by 2, and you would think it'd get 25. So you would think 50% of the time it would land on heads. But based on Liz's results, the experimental probability of the coin landing on heads is, 20 times out of 50, that's 20 divided by 50, and that's going to give you 40%. The theoretical probability is, blank than the experimental. Well, the theoretical would have been 25 times, and the experimental was just 20 times, so the theoretical probability is greater than the experimental probability in this particular experiment. Jess spins a pointer 25 times and finds an experimental probability of the pointer landing on 3 to be 4 out of 25 times, or 16%. The theoretical probability of the spinner landing on 3 is 1 over 4, or 25%. Why might there be a significant difference between the theoretical and experimental probability? Well, more trials are needed. After she conducts more trials, the experimental probability should approach the theoretical probability of Jess's event. In other words, the more time she does it, the more she's going to come closer to that 25%. The table shows the results of a survey of 100 people randomly selected at an airport. Find the experimental probability that a person is going to City E. Well, in City E, it's only 8 times out of 100. So the experimental probability is going to be 8 over 100. 8 divided by 100 will give you 0.08. And if I move the decimal over twice, it becomes 8%. Number 11 says the theoretical probability of selecting a consonant at random from the list of letters in the alphabet is 21 out of 26. That makes sense because A, E, I, O, U are vowels, and that's 5 of them. So 26 minus 5 is 21. Wayne opens a book, randomly select a letter on the page, and records the letter. He repeats the experiment 20 times. He finds the probability of landing on a consonant 60%. How does the theoretical probability differ from the experimental probability? What are some of the possible sources for this discrepancy? Well, the theoretical probability is much greater at about 81%, while the experimental probability was 60%. Remember, 21 divided by 26 will give you about 81%. We only got 60%. The experimental probability may be less because the distribution of letters and words is not random. There are more vowels than consonants on a page. Remember, every word needs a consonant, but not necessarily every word needs, I'm sorry, every word needs vowels in it, but, and that's going to be A, E, I, or U, but every word does not necessarily have all the consonants in it. So in this particular case, we're saying that vowels are going to be picked more than the percentage that we thought. High order thinking. 7 different names are written into sticks and placed into a cup. A stick is chosen 100 times, out of which the name Grace is chosen 23 times. How do the theoretical probability and experimental probability compare? Explain why there is a discrepancy between them, if there is any. Well, the theoretical probability for choosing Grace to stick is 1 out of 7. Remember, they said 7 sticks were written, or 7 names were written on the sticks, right? So that's 14%, while the experimental probability was 23 out of 100. Remember, Grace's name came up 23 times out of 100 times being drawn. And that's 23%. The person choosing sticks may not be mixing the sticks before drawing them from a cup. The selection might not be random if the person can see the names written on each stick. Now remember, if he can see them, he might purposely be picking Grace. Number 13, each of 3 friends flips a coin 36 times. Angel records tail 20 times. Michael records tails 17 times, and Fernanda records tails 23 times. Find the relative frequency with which each friend records tails. Well, Angel had the probability of tails 20 times out of 36. Michael's probability for tails was 17 out of 36, and that's 47%. And Fernanda's probability for tails is 23 out of 36, which is 64%. You see, all we've got to do is put the number of times it happened over the number of attempts, and then divide the numerator by the denominator to get our percentage. And B says which friend has a relative frequency that is closest to the theoretical probability of flipping tails 36 times. Well, remember, if we flip it, we're always going to say that flipping a tails is 50%. So which one of these is closest to 50%? I'm going to say Michael. And I'm right. The relative frequency for Michael is 47%, which is closer to the theoretical probability of 50% than anyone else's relative frequency. Well, looks like that's all of the homework. Great job, and remember to submit your homework either on Microsoft Teams, my email, or my as a text to my phone. And I'll go ahead and get those grades in. You have a great night.